Okay, today we will discuss in this video lecture the basic function of air vessel. Okay, these all are the air vessel and it is connected with suction line and delivery pipe. Okay, it is a single acting reciprocating pump. So first of all I will introduce about the basic component, then after we will discuss the function of the air vessel. Okay, this is a piston. It is connected with the connecting rod. Okay, and it will slide inside the cylinder. Okay, it is a cylinder and this motion is called reciprocating motion. Okay, to and from motion. Okay, it is called reciprocating motion, so it is called reciprocating pump, and it is a positive displacement pump. Why it is called single acting? Because it is acting on one side of the cylinder. Okay, for example, this piston will slide and both the side suction will be take place and delivery valve will be there. Okay, then it is called double acting. So the air vessel is required in single acting pump. The basic need of the air vessel is to maintain the continuous flow or maintain the velocity throughout constant. Okay, how can it possible? Okay, so for that first of all I will introduce about the working principle of single acting reciprocating pump, then after we will discuss the function of air vessel. Here you can see that whenever the piston will travel, okay, this is called IDC, inner dead center, and this is called ODC, outer dead center. Whenever the piston will travel from inner dead center to outer dead center, at that time the negative pressure will be generated inside the cylinder, and we know that negative pressure means vacuum pressure below atmospheric pressure. At that time this suction valve will remain open and delivery valve will remain closed. So at that time it will allow the fluid and it will enter into the cylinder. It is called suction stroke. During the delivery stroke, the piston will travel from ODC, outer dead center, to inner dead center. At that time this suction valve will remain closed and delivery valve will remain open, and this fluid is pressurized and it will deliver to the delivery tank. Okay, this is the basic working principle of the single acting reciprocating pump. But in that case there is no any continuous flow. So here you can see that near the suction line, okay, here you can see that it is connected with the air vessel, same as at delivery side in delivery pipe. Here you can see that it is connected with the air vessel near the cylinder. What is the function of this air vessel? During the suction stroke, this suction valve will remain open and this delivery valve will remain closed. So at that time the fluid is taken by this air vessel, same as during the delivery stroke. Okay, so during the delivery stroke this delivery valve will remain open, then and this suction valve will remain closed. Okay, so at that time the fluid is taken or liquid is taken into the air vessel. Okay, so it is a one type of reservoir. Okay, same like as in IC engine. Okay, we are using flywheel to store the energy. Here you can see that on top side of the air vessel the air will be there. Okay, here you can see that here also air will be there. This is represented by dots. This is air particles. Okay, so during the suction stroke we know that during the suction stroke suction valve will remain open and delivery valve will remain closed. Whenever this valve will be remain closed, at that time the fluid is taken into the air vessel and it will compress the air, because we know that air is a gas and it is compressible in nature. So at that time whatever the extra fluid is there, it is stored in the air vessel and it will compress the air, and we know that the nature of the air, it's compressible in nature. Same like as in delivery stroke, this delivery valve will remain open, so it will allow the fluid to the storage device, and this valve will remain closed, means suction valve will remain closed. So at that time the fluid is taken into the air vessel and it will compress the air. Okay, because we know that air is a gas and it is compressible in nature. So in both the vessels, okay, the fluid will be stored for a particular time or a short duration. Okay, so it is a one type of storage device, same like in IC engine. We are using the flywheel to store the energy, and whenever it is required it will supply. So it is a one type of storage device and whenever the required the fluid, at that time it will supply. So throughout the process, okay, in a suction pipe and delivery pipe the fluid will be present, so we can maintain the constant velocity in a single acting reciprocating pump to achieve the continuous flow. This is the basic need of this two air vessel, in which case it is required to fill up the line. Whenever the suction line is empty, at that time this air will be expanded and this fluid suction line, and it is fill up the suction line. So continuously a suction pipe and delivery pipe is filled with the liquid, and we can maintain the constant velocity throughout the working of single acting reciprocating pump.